All right, I think it's going to work. Okay, here we go. So first of all, let's talk about what a radian is. All right, so I've got a circle here, and radians have to do with angle measures. And so what I want to do is let's draw a circle here. And I've got this lovely little candle lid, which is going to allow us to draw a very fantastic circle. All right, so there we've got a circle. Now this circle has to it a center. All right, and I feel like that looks fairly centered. Might be right there. And so would you agree that on our circle, that is a radius? Fair enough? We all agree to that. That's a radius. All right, I'm going to have this stick out a little bit here so we can see it when I put the circle back on here. So what I've done is taken a piece of string here, and I have marked off the distance of the radius as units. So these are radii, okay? So I've marked off a bunch of them on the circle for us, okay? And would you agree if I come, let's draw this like so. If I come around to the half circle, that's 180 degrees, right? So what we normally think of as 180 degrees. So here's what I'm going to do. I'm going to put this little circle on here, and what we're going to do is, let's see if you can see this. I'm going to put the very first mark right where that little radius sticks out, okay? So you see where there he is. He's peeking out over there. And I'm going to wrap it around here, and what I'm going to do is over here where the second mark is, I'm going to put a little mark, okay? So that distance is one radius, right? Because each of these is a radius. So what I'm going to do is draw from this mark over to here to there. This angle measure right here is 1 radian. That's what a radian is. A radian is the angle measure that gives you an arc length exactly equal to the length of the radius. That's what a radian is, okay? So the question is, how many radians do you see in a whole circle? So what I like to do is, let's take a look at just a half circle. So we'll go to the pink marker here, and we'll mark off a half a circle, because that's about all of this that I marked up on the string. So put my little lid back on there, and so I'm going to put my first mark right here, and there's 1, there's 2, over here is 3, you see the 3, and there's a little bit, right? So what if I told you that it's about 3.14 radians? That's pi. You're right. Which brings up an interesting point. We talk about radians in terms of pi. So this distance right here, this angle measure, is pi radians. And would you agree pi radians then is equal to 180 degrees? Because that half circle is 180 degrees. So this is a truth. So pi radians equals 180 degrees. So this is really cool. We can now convert back and forth between degrees and radians using the fact that pi radians is the exact same thing as 180 degrees. Let me show you how we do that. I have 45 degrees, okay? So I'm going to convert it to radians. So 45 degrees, I can multiply this by pi radians over 180 degrees. All right? And the reason it's this way and not flipped upside down is because I need the degrees on the bottom to cancel out, and I need to end with radians on top. Now, how many times does 45 go into 180? 4. So, this equals pi over 4 radians. There we go. Pi over 4 radians. Now, over here I have 3 pi over 4 radians, and I want to convert that into degrees. So I'm going to do something similar, but yet opposite. So 3 pi over 4 radians, I'll just put RAD, times 180 degrees over pi radians. Okay, I flipped it upside down because I have radians, which I want to get rid of, and I want to end with degrees. So now, do you see how the pi's cancel? It allows you to get rid of the pi's. And then I've got 3 times 180, and then divide by 4 gives me 135 degrees. So this equals 135 degrees. Pretty cool? So that's converting between degrees and radians. We're going to do a lot of that because this unit, which we'll be working on some more on even Monday, is going to set up for us something called the unit circle, which is key to all of trigonometry. Okay, so let's go ahead here and do a little bit of vocabulary. So a central angle, and I'm going to go ahead and underline that, of a circle is an angle with a vertex at the center, and the intercepted arc is the portion of the circle with endpoints on the side of the central angle, which means here and here, and remaining points within the interior of the angle, meaning in here. So that's an intercepted arc, all right? So you see visually what an intercepted arc is. Now this goes over what we just learned. A radian is the measure of a central angle that intercepts an arc with length equal to the radius of the circle. So that's what a radian is. And radians, like degrees, measure the amount of rotation from the initial side to the terminal side. So we have right here what I just showed you how to do. So this would be good to highlight. So to convert degrees to radians, do this to convert from radians to degrees. And notice these are just flipped upside down from each other. All right? So what is the degree measure of an angle of negative 3 pi over 4 radians? We actually just did this example. So what do you think it is? Negative 135. If you have negative in radians, you have negative in degrees. If you have positive in radians, you have positive in degrees. So what is the radian measure of an angle of 27 degrees? Well, we're going to need to calculate that. So let's go ahead and do that. So I have 27 degrees. Now, what's going to go on top? The radians. So pi radians over 180 degrees. Now, when we have radians, gosh, it's super nice if we can keep them in fractions. So I'm going to try and do that. And I'm wondering if 180 divided by 27, and it does not, but I know I can simplify some stuff. I can take 9 out of them. So 180 divided by 9 gives me 20. And this gives me 3 up here, taking 9 out of it. So this is 3 pi over 20 radians. Fair enough? Fair enough. Okay. Now, this gets kind of interesting. What are the exact values of cosine theta and sine theta? And remember, cosine theta, that equals x, right? And the sine theta equals the y on the unit circle. So when theta equals pi over 4 radians. So first of all, for us, this is a lot easier if we have this in degrees, right? Because that's what we know. So let's convert it to degrees. So pi over 4 radians times what? 180 over pi radians. And this is going to give us 45 degrees, right? So that's a 45-degree angle. So let's go back to what we were doing the other day. And we'll start with our lovely circle. And let's draw the X and Y axis. Okay, so let's draw that 45-degree angle. Okay? And if you recall, we then make a triangle out of it, right? And what kind of triangle is this? 45, 45, 90 triangle. And remember, we label this is our X value, this is our Y value, and in our unit circle, this is 1. So do you remember, how do we get our X value if we know the hypotenuse is 1? Divide by the square root of 2. So X is going to be 1 divided by the square root of 2. We need to rationalize the denominator, and this gives us the square root of 2 over 2. Now, since that is our X value, let's put our little theta right there. This happens to be cosine pi over 4. All right? Because cosine is our X value. So let's go ahead. What is the Y value then? The same thing, right? Because in a 45, 45, 90 triangle, X and Y are the same thing. So Y equals the square root of 2 over 2, and this is going to equal the sine of pi over 4. All right? I know this is a lot of steps all put into one particular situation. Let's go through one more example like this. All right. So what are the exact values of cosine theta and sine theta when theta equals 7 pi over 6 radians? So first thing, let's convert that to degrees. So we have 7 pi over 6 radians times what? 180 over pi radians. Okay? So when you calculate that, can anyone tell me what that is?
Oh, there's a 7 there.
So 7 times 30 is 210, right? Okay. So equals 210 degrees. So what quadrant is that going to fall in? Second. So let's go ahead and we'll get our X and Y axis drawn. Let's put our circle on there. Now, let me ask you this. We need to put it in the appropriate spot here in the second quadrant. How far away is this from, let's say, 180? Yep, it'll be down there, I'm sorry, in the third quadrant. So how far is it away from 180?
30.
It's 30 degrees, right? Okay. So it's a lot closer. So about a third of the way. What do you think? How does that look? Okay. So now we need to make our triangle. Now, would you agree what we've created here is a 30, 60, 90 triangle, and it's for the reason you just mentioned. This angle right here is 30 degrees because 210 is 30 away from 180, right? Okay. So this is a 30, 60, 90 triangle. This is X, this is Y, and this is 1. So let's do this. It's always easier to go to the short leg first. So let's go to Y first. How do we get Y if we know the hypotenuse is 1? Divide by 2. So Y equals 1/2, right? Now, let me ask you. When we're not in quadrant 1, we start to have to think about the sign of our X and our Y values. Is this going to be positive or negative? Negative, because we are down here below. So this is negative. So Y equals negative 1/2. And Y happens to go with the sign. So this is the sine of 7 pi over 6. Okay, now, how do we get from the Y to the X value? Right, because our conversion is to go from the short leg to the long leg. How do you go from the short leg to the long leg? Multiply by square root of 3. So this is going to be negative 1/2 times the square root of 3. And is this going to be positive or negative, just to be sure here? Negative, because we're down here to the left of the origin. So this is negative square root of 3 over 2. The X value is the cosine value, so this is the cosine of 7 pi over 6. All right? There we go. One last thing that we need to cover as we run out of time today. Measuring or calculating arc length. There's a real quick formula for doing this, but it uses radians. So it's really important that we get familiar with and can use radians. And if you go down here to the bottom of the page, there's a box that explains what this is. Remember, this is your arc length. S is your arc length. In order to calculate that arc length, it says for a circle of radius r and a central angle of theta, remember theta is our variable for angle measure, in radians. It has to be in radians, not in degrees, in radians. The length S of the intercepted arc is S equals r theta. R is the radius. Couldn't be an easier formula, right? In radians. Got to be in radians. So let's go ahead down here and we're going to do a quick example. Use the circle at the right. What is the length to the nearest tenth? So this time we're going to be putting this in our calculator. So how about the length S? So S equals r theta. What is the radius from the picture? 3. And what is theta? What's theta in our picture that goes with the arc length S? That would be this angle. 5 pi over 6. So 3 times 5 pi over 6, and it says to the nearest tenth, so as a result we're going to want to get our calculator out now. Don't forget to find your pi key. You know what, I'm so livid. I left my good calculator sitting at home and it makes me very unhappy. So I've got the less cool one today. So 3 times 5, right here is your pi key. So second, there's your pi key, and then divided by 6, and this is 7.9, and that would be inches, right? Because it says nearest tenth, right? So 7.9 inches.